Unit 4 review. I will work with you on the even problems. Number 2, an equilateral triangle is always isosceles. That is true. Because isosceles means at least two sides are congruent. And on an equilateral triangle, all sides are congruent, all three. Number 4, a scalene triangle is sometimes obtuse. I would say true. Number 6, an isosceles triangle is never right. That is false. Because you can have a 45, 45, 90 triangle. Number 8, an isosceles triangle is always right. Now that's false as well, because there are several types of isosceles triangles, not just the 45, 45, 90. It can be 35, 35, 30. I'm sorry, not 35, 35, 30. 35, 35, 110. Number 10, an isosceles triangle is sometimes scalene. False. Because angles will be, the larger the angle, it'll be crossed from the larger side. And on a isosceles triangle, you have to have two sides the same. On a scalene triangle, no sides are the same. Number 12, an acute triangle is never equilateral. That's false. An acute triangle can be equilateral sometimes. It's not always, but sometimes. On number 14, they would like for us to find the measure of angles 1, 2, and 3. I would first find angle 1 because I know that 1 together with 50 and 90 would make 180. I also know that if I already have 90 degrees taken care of, 1 and 50 would need to make 90 more. So the measure of angle 1 plus 50 should be 90. So that means the measure of angle 1 is 40 degrees. Now, to find excuse me, sorry. Um, I would find angle 2 because you know that this is also going to be a 90-degree angle. So you have 70, 90, and angle 2. So I know that the measure of angle 2 plus 70 is 90 degrees. So that means angle 2 has to be 20 degrees. And now to find 3, there are several ways I'm sure it can be done. For example, you know that the 50-degree, number 2, and number 3 together will be 180. So that means the measure of angle 3 plus 2, which we said was 20 degrees, plus 50 degrees is 180 degrees. So the measure of angle 3 plus 70 degrees is 180. So that means the measure of angle 3 has to be 110. one would like for us to find the value of x. What you should notice is that there are two large triangles overlapping to form a smaller triangle. So the first thing I would do is find the missing angles of the larger triangles. For example, this larger triangle is missing this corner here. To find that corner, I would take 39 plus 81 and get 120. And I know I would need to subtract that from 180 to get that missing piece. So it would be 60. Then I would find the missing piece for the other triangle. So that would be this corner here. I know I would take 74 plus 52, and that would give me 126, and subtract that from 180, and you would get 54 degrees. And lastly, I would take those two angles I just found, the 60-degree and the 54, combine them to help me find the last angle in that smaller triangle. And when I find that last angle, it's going to be congruent with x because that's a vertical pair. So that's 60 plus 54 gives me 114, and then subtract that from 180, and that would be 66 degrees. So that's x. Number 18, again, wants us to find the value of x. This looks a lot like an exterior angles setup because you have your remote interior and your remote interior, and you have your exterior. So R plus R equals E. So that means 5x plus 2 plus 4x equals 11x minus 22. First, I would combine 5x with 4x to get 9x plus 2 equals 11x minus 22. Then I would subtract 9x from both sides, so that would give me 2 equals 2x minus 22. Then I would add 22 to both sides, so that would give me 24 equals 2x. And last, divide both sides by 2, so 12 equals x. Number 20 would like for us to name all possible ways to prove that triangles are congruent. So I will list them and then provide a description of each. So the first one is side, side, side. Second one would be side, angle, side. Third, angle, side, angle. Fourth, angle, angle, side. And fifth, hypotenuse leg. So again, the first one is side, 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 where you're given 3 congruent sides. On side, angle, side, you're given 2 sides with included angle. On angle, side, angle, you're given 2 angles with included side. On angle, angle, side, you're given two angles and side opposite one angle. And lastly, the hypotenuse leg, you're given the hypotenuse and a leg. HL only works on right triangles, and the hypotenuse is always across from the right angle. On 22, it tells us that segment PM is congruent to segment PQ. PM is here, PQ is here. NP bisects M and Q, so that means this angle is congruent with this angle. So it's MP, M and Q has been cut into two equal angles. Now it wants us to tell what triangles are congruent. Triangle MNP is congruent to which triangle? Well, we also know that both small triangles share the side NP. So we have side angle in both triangles. And we know that that is not proof or evidence of congruency when we're talking about triangles. So these triangles are not congruent. On number 23, it tells us that segment NP bisects M and Q. So that means this angle is congruent with this angle here. Then it also says NP bisects MPQ. So that means this is congruent with this. And then it would like for us to fill in the blanks. Triangle MNP is congruent to what? Again, we know that NP is a shared side by both triangles. So we have angle, included side, and angle. So we do have congruency. MNP is congruent to QNP. Forgot my triangle symbol. By angle, side, angle. Therefore, MP is congruent to QP by what? So MP is here, QP is here. They're congruent by CPCTC, which stands for corresponding parts of congruent triangles is congruent. Corresponding parts of congruent triangles are congruent. Because we proved that they were congruent, then of course all the parts are going to be congruent or match as well. Oh, 24 wants us to find the value of x. This is an isosceles triangle because both of these sides are equal. And then it tells us that 2x plus 3 is the corner angle. Well, on an isosceles triangle, the angles that are opposite the congruent sides will be the same. So that means we have 2 times 2x plus 3 plus the 90 degrees is 180. In other words, 4x plus 6 plus 90 is 180. Then I could subtract 90, so that would be 4x plus 6 equals 90. Then I could subtract 6, so that would be 4x equals 84. And then divide both sides by 4, so x equals 21. Alrighty. 26 wants us again to find the value of x, and they give us two sides. They also indicate that the two bottom angles are congruent. So since they told us the two bottom angles are congruent, that means these two sides across the given angles are congruent. So this is an isosceles triangle. So that means you can say 2x plus 6 equals 3x minus 6 and solve for x that way. So the first thing I would do is subtract x on both sides. So 6 equals x minus 6. Then I would add 6 to both sides. So that means 12 equals x. And last but not least, number 27. Alrighty, so it wants us to fill in the reasons for the proof. The first reason, always, 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 is given. Then it tells us that angle ADN, which is here, is congruent to YND, which is here. And that is true because we were told in statement 1 that the two lines are parallel. So since those two lines are parallel, those angles are going to be congruent because they are alternate interior angles. So because those two lines are parallel, the alternate interior angles are congruent. Then it tells us that segment DA is congruent to segment YN. That was also part of the given information. So let's label that on our picture, which it already is by the tick mark. Then it tells us that segment DN is congruent to segment DN. Well, that's this piece right here, this side that both triangles share. And since it says the same thing, it's a reflection, so it's the reflexive property of congruence. Reflexive property of congruence, because it says the same thing forwards and backwards. And now it tells us that triangle NDY is congruent to triangle DNA. And that is true because we have side angle side. So side angle side postulate. Or theorem. I can't recall off the top of my head if it's a theorem or postulate right now. And then it says that angle Y is congruent to angle A. Here's Y, here's A. And that is true because the triangles are congruent. So that means their corresponding parts are congruent. So corresponding parts of congruent triangles congruent.